Good morning, everyone. We will just give it about another 4 or 5 minutes as people are logging on before we get started. We'll give it just a few more minutes while people are logging on. A few more minutes and we'll go ahead and get started. Okay, we can go ahead and get started. I want to thank everybody for joining today. Today is a brand new topic of our webinar series. It's on two-hand controls beyond just two buttons. This is going to cover some myths, a little more explanations and education on two-hand controls. So what I'd like to do is do a quick intro for anybody that's new on these webinars. My name is Sean Mantell, owner and application engineer of PowerSafe Automation. PowerSafe Automation is a turnkey machine guarding solutions company that provides services from assessment all the way through custom design, manufacture and assembly, and installation of machine guarding projects, mostly on legacy machines nationwide. So today's webinar, as all of our webinars, it's going to be based on the engineer portion of it. We don't get into the administrative controls with signs and training and things like that. So as we go through this, just know that we're going to be focused on in the engineering portion of it. There are people on to help answer some quick Q&A during the, if you want to drop it in the chat. There'll be a little bit of time at the end for some Q&A, and then if you want to sidebar some additional conversations after the webinar, we can schedule that as well. I'm going to go ahead and share my screen here in a minute, turn off my camera so I can share the PowerPoint. This PowerPoint is something that you will get at the end. Also a recording of this webinar so that you've got something to reference back to, go back over. You may miss something today. You may want to go back and double check things, share it with your team, things of that nature. Everybody should be able to see my screen now. The PowerPoint just starts out with the logo, and as I mentioned, engineering your safety is our tagline, because that's what we focus on. We focus on trying to engineer the operator, the human interaction away from the hazard by guarding and controls. So as we go through this, keep that in mind. Today's presentation is going to be on two-hand control systems beyond two buttons. There is a misconception about two-hand controls. I go into a lot of facilities where people will say, well, we have two-hand controls on the machine. And then through some checks and questions and testing, they technically are two buttons, but not a two-hand control safety system. So that's what we're going to discuss today. So the expectations of this training is going to be understanding the purpose and the limitations of two-hand controls, recognizing the difference between two buttons and a properly designed two-hand control system, identify common design and application mistakes found in the field, understand why two-hand controls primarily protect the operator, not everyone around the machine. Learn how physical guarding and e-safety devices can help create a more complete safeguarding strategy. Two-hand controls is a layer of safeguarding, not the entire system. So let's get into what are two-hand controls. It's a safeguarding control device that requires simultaneous action of the two buttons to initiate hazardous machine cycle. So just because it has two buttons and someone says, hey, I have to hit both buttons. Well, you have to hit both buttons simultaneously. If someone says, I can press this and then I have to hold this one or otherwise it won't cycle, that's not simultaneous action. We'll get into here in a minute what it means that they can do both, but operators can defeat a button if they're both not simultaneous action. If it's simultaneous action, the process is a safe process then. The purpose of this is to keep the operators from the hazardous motion on the machine. Likelihood of hand injuries, whether that's crush or nip points, whatever the hazard on that machine is. But keep in mind, this protects the operator, not necessarily the other person. If there's someone else in the area, they have free reign. If we just assume that two-hand controls is safe enough because the operator is protected. Some appropriate applications that you might find these in is presses, welders, riveters, some saws and cutoff machines, assembly equipment, assembly presses, stacking machines, machines where it's interacting with the machine to do a operation or a cycle. Areas where the applications would not work would be where you're not staying engaged continuously. If it's an automatic production line, two-hand controls aren't start buttons. cycle start buttons because the two-hand controls is to keep your hands preoccupied so that you're not putting them in the machine. Well, if they use a cycle start buttons and there's no other guarding on the rest of the machine, you're not going to want to use that on production lines or continuous feed units because you're going to come off the two-hand controls unless you're going to sit there the entire time, and then that defeats the purpose of automatic production lines or continuous feed, frequent access into the machine. So here's just some ideas that as you're looking around your shop, do I have two-hand controls? Do I have machines that should have two-hand controls? Are there machines that shouldn't have two-hand controls? And I need to look at different solutions. So these are just some ideas to help do a little bit of brainstorming. Two buttons are not two-hand controls. Two buttons are simply input devices. Installing two push buttons that are not tied together as one doesn't automatically create compliant two-hand control systems. A true two-hand control is a complete safety function. There's circuitry in there. There's an anti-tie-down relay, which we will talk about. Basically, it ties those buttons to make them virtually one. So what could happen is in this picture, if you've got this button here and this button, both, this is not, the spacing is wrong. So this is showing you it's not a two-hand control. But what I'm explaining here is if someone wanted to take some duct tape and tape this button down and then just press this button, and they said, well, I activated both buttons. Well, then this hand is free to do whatever it wants. So this is not a proper two-hand control. What you saw before here, that would be because of spacing. I can't, there's controls in here that are tying these together. Basically, you're creating two buttons and creating a single infrastructure. Hold to run versus cycle initiation. That's another one to also consider. Just because you have to simultaneously hit both buttons to start the cycle of the machine doesn't mean you're finished evaluating is your machine safe or not. You now determine, okay, my two-hand controls are working correctly because I have to hit them both at the same time. But if it's a cycle initiation where you hit both buttons at the same time, and then you can come off of it, but the action is still moving, maybe a cylinder's coming down, maybe a door's coming down. If you don't have any extra protection of, I got a set of light curtains there, I'm going to hit the two-hand controls, but if I stick my hands in, then the light curtains are going to be an extra measure that I can't get to the hazard. Maybe there's a door coming down and it's got a bumper sensor like on your garage doors that if I hit that, then the door will go back up or stop. So you have to look at what is your system doing. When it doesn't have that additional safeguarding, the operator may either need to keep both hands on and maintain those buttons through the entire cycle, or add some additional machine guarding to your machine. The design functionality should be evaluated when you're doing assessments of the whole machine as you're looking at the hazards. What's the operation? What's moving? What am I trying to do? What's cycling? Is the hazard only going down versus up if it's a vertical press? Is it side to side? Is it a saw that the blade drops back down in between? So you need to also evaluate, not just walk up, test your two-hand controls, but also make sure that once you let go, what's happening? Motion stops. There's extra safety guarding on there. The motion retracts and it's not hazardous in the retraction. So you have to make sure that you're assessing that as well. I'm going to show a video here that gives a quick overview of what we just talked about that can explain this a little bit. This is on our YouTube channel. We have a lot of videos, some of their explainer videos or tutorials, some of its application videos, but this one on there will help explain that. And this might be a good video that you can show to your team, maybe some operators, maybe if you have a safety committee, you can show this video to them. Here now. So in this video, you can see that there is closed caption on it. I wanted to show the video because it gives a visual of what I'm doing. We're going to send this video out. There is audio in here to be able to explain everything that's going on here and everything that I'm discussing on this webinar. But this gives a nice visual. You saw where the duct tape was wrapped around the button and held down, and then they reached into the machine. And then the machine was cycling because they accidentally hit the other button. So it's a really good video to quickly give you an overview of that. Someone can watch this minute and a half and get a good idea of what two-hand controls mean. Key design considerations. We're going to get into effective systems for two-hand controls. Anti-repeat. Anti-repeat prevents the machine from initiating another hazardous cycle simply because the buttons remain actuated after previous cycle. You basically, if you try to override it, you try to do it again, you try to resume, reset your system so that you can reset the condition. The machine knows that the hazards have been cleared, and then I can repeat my action from there. Anti-tie down. It's making sure that one button isn't held, and then you can cycle the second one. That's probably the biggest misconception that I see out there is that simultaneous action is not happening in that cycle. And when you walk up to the press, the first statement is, well, there's two-hand controls on the machine. Test it. Press, hold down one button, press the other one. Reverse that and do it on the other side. And then hit them both at the same time. And then hit them at the same time and let go. Run through some of those tests to validate where you're at with your system. And then ensuring the two-hand control station is located far enough from the hazard that the operator can't reach. Because if you do let go of it, the issue with safe distance is going to be, if I let go, can I get to the hazard before the hazard stops? If there's a coasting action, if the door's going to drift down, if I can get to the hazard by releasing the buttons because I've got it right up against the machine and I can slip my hand off fast enough to get into the hazard, you need to make sure that you're at a proper safe distance for that, of where you're going to put that. Reset and restart behavior. After a stop, fault, or interruption, the machine not unexpectedly restart. A restart should require deliberate operator action. So you want to make sure that, like I mentioned, resetting your conditions so it doesn't restart. If it's a fault, your safety circuit should have to be restarted, and your two-hand controls is part of your safety circuit. You want to make sure that the anti-tie down system is working properly. Your buttons aren't stuck together. So make sure that you reset your safety condition. Functional safety, safety-related parts of the control system should be designed in a single fault. So a single fault does not result in loss of safety function or fault. That's redundancy in your safety circuit. That's going to give you your proper functional safety. I do want to note that I do have webinars that we do talk about control reliability for functional safety. We do talk about, we have webinars on machine guarding. We do one on toolkits to be able to run through checklists to help with some of these self audits, maybe before you bring in a machine safety company to review. but the functional safety has to do with the redundancy in the system that gives you the proper performance for that machine. A lot of times those are found on risk assessments, having someone come in and look at your system, test those two-hand controls, maybe check your control panel, maybe look at the devices. Are your devices outdated? So those are things that can happen on a risk assessment, but you want to make sure that you've got the right components in there. If your buttons are outdated, if they're old, if they're sticky, if they're broken, you want to make sure that you're doing that. Key takeaways is that a properly designed two-hand control is a complete safety function, not simply two buttons wired into a control circuit. A lot of redundancy in what I'm saying is just repeated because that's the biggest issue so if we solve this one issue in the field, we're going to solve a lot of the issues with the two-hand controls. So make sure that your two-hand control system is designed properly. It's a small piece. If you walk up to a big machine with guarding, no guarding, whatever that is, and you're looking at this box that just has two-hand controls on it, you're like, well, this is just one small piece of the machine. That one small piece is a major part of, is that operator going to be safe or not? So now we get into some assessing of your two-hand control system. What to evaluate after asking, is this two-hand control effectively reducing the risk? So if you're going to do some self-audits, just to double check, do some homework, is this reducing the risk? Am I safe? Are these buttons compliant? So here's some things that you can be looking at. What's your button location? Are the buttons located far enough from the hazard to prevent access during hazardous motion? That's where I mentioned, make sure you have your safe distance. Make sure that you can't move your two-hand controls closer to the machine. Make sure it's not right up against the machine where if there's no additional secondary guarding, that you can't stick your hand in the hazard while the motion is stopping or slowing down after you release your hands from the buttons. Can you reach that hazard before the machine stops? So button locations is critical. Button spacing. Button spacing is also very critical. You can see in this picture, they're spaced out. There's distance between the buttons that you have to have these apart. Reason being is the distance between your pinky and your thumb, or something you can hold in your hands that you can use one hand to spread your fingers out. On that one picture that I showed you with the buttons right next to each other, someone can use two fingers to hold those buttons down, and then you've got your other hand free. You have to make sure that those buttons are spaced apart so that they can't be touched or cycled with one hand. Are they mounted in a way that promotes intentional ergonomic use? Ergonomics is still safety. So are they going to be overhead? Are they going to be too low? Are they going to be at a distance off the floor that is ergonomically safe? Are they on the side, on the top? How am I using this every day? Is it angled a little bit? So you want to make sure that you're looking at how are they using this operation so that you mount those two controls in a proper spacing, direction, location, that it's comfortable and safe to the operator. Signs of defeat or bypass. If someone's taped a button down, if they've zip tied them, put weights on them, things that they can hold the button down. Mechanical modifications or damaged components. Maybe someone stuck a small knife or a little screwdriver in one of the buttons to jam it down in the down position. Evidence of operators defeating the intended function, that needs to be handled internally with leadership, but at least while you're walking through a shop or you're walking up to a machine, those are things that you visually could see on a machine. as long as you're looking for them. So look for these simple techniques of an operator's trying to defeat them. If they can defeat it with tying a button down, the system wasn't developed correctly. So if you see that, that's the time to throw the red flag and say, hey, you know what? We need to talk about this. Stop the machine. Let's figure out what's going on here so that we can create a plan to fix this. Functional validation. Has the system been tested to verify proper operation? That's where I mentioned, walk up to it, hold one button down and then press the other one, reverse that cycle. That's a simple test to know, are these buttons tied together? Do anti-tie down and anti-repeat functions operate as intended? Can I start it and stop it and start it right away? Does it go back to home position? Is it starting when it's not supposed to? Is it stopping the functions performing correctly? Is it stopping? Is it holding? Is it retracting? Those are all questions. There is no one single answer on that for that validation of, is it functioning properly? Because you may have a hazard on the retraction. There may be no hazard on the retraction. The hazard may be just a crushing hazard going down, but then there's no hazard on the return. So you need to make sure that you understand the tasks that are being performed on that as well, so that you can properly validate, yes, the buttons themselves are working correctly, but that doesn't mean that it's working correctly operationally for that machine. The buttons are good, but the sequence of operations could be incorrect. And then, has the required safety distance been calculated? You need to have the buttons away from the hazard. Minimum's going to be about 3 feet, but you also have to take into consideration, how long does that take to stop? It's the same thing with light curtains. If it takes time to stop, that 3 feet, you've got time to get to that. If it takes 5 seconds to stop, then two-hand controls, releasing your hands from the buttons, you're going to get to that hazard too fast. Does the button location account for machine stop time, approach speed, which I just mentioned of, you know what, this is 3 feet away, 36 inches, but it takes a second, so I got to be 60 inches away. So these two-hand controls aren't far enough. I don't have room on the floor to move this out another couple feet, so I'm going to maybe put some different guarding on the machine. So key takeaways on this one is going to be that two-hand controls, is that a two-hand control is only as effective as its design, installation, validation, ongoing maintenance. Don't install a system and assume it's going to last forever. Make sure that you continue to reassess the machines, the controls. If your fixture changes, maybe you introduced a new pinch point or crush point. If you modified the fixture, maybe each die that you put on it is a different shape. Maybe it takes longer to move that part that you're putting into the machine. If you're putting a part that's a pound and a part that's 20 pounds, maybe that's going to move a little bit slower into the machine. So maybe it's slowing down your safety distance. So those are all things that have to be considered, not just testing the two-hand controls. The biggest thing is two-hand controls, is it working? And then, is it working correctly for the operation? Then I like to also look at not just the operator. So many people focus on the operator. Yep, the operator's safe. Two-hand controls work. It's right for the sequence. So as long as they stay back here, keep their hands on, then we are safe. Well, the operator is most likely safe, but that doesn't mean anybody else around in the area is safe. We ask ourselves, why would anybody stick their hands in moving machinery? But people do, unfortunately. So we have to protect for the other person as well. So think of this as safety 360. That's going to be, am I covered all the way around the machine? Legacy machines makes it extremely difficult to give you full engineered systems, 360 degrees, but you could at least do 270 degrees, and then two-hand controls on the front to get you closer for risk reduction. Maybe it's a set of light curtains on the front of a assembly press. So you've got guarding on the back, guarding on the sides. Maybe it's a vertical door on the front. Maybe it's a set of light curtains. So if I'm the operator and I press the two-hand controls, someone else walks by, they stick their hands through the guard. That's a set of light curtains. Then it stops the machine. If there's a door on all the way around and there's a door on the front, nobody can get in. So the two-hand controls protects the operator. Physical guarding, interlock doors, light curtains, those type of safety measures protect the other person. It also protects the operator. If you can't get enough safe distance with the two-hand controls, then you can add some additional guarding to the machine to make sure that you're safe. Some myth versus facts. This would be a good slide to share with people so that they know if it has two buttons, it's safe. Two buttons alone do not create a complete safeguarding function. So be careful. Again, two-hand controls, two buttons, two different things. Two-hand controls eliminates the need for guarding. They primarily protect the operator initiating the cycle. So guarding 360, add physical guarding, add light curtains, add scanners, add safety radars, making sure that you're protecting everybody, protect the environment, not just the operator. Older machines are grandfathered. That's a myth. Machine modifications, workplace safety responsibilities still require risk evaluations and risk reduction. No matter the age of the machine, if there is a hazard on the machine, it's our responsibility to make sure that that gets mitigated through some sort of risk reduction. Continue to ask, who else is exposed and how does my system work? So is there someone else walking through? Is this press in an aisle? Is there traffic in this area? Do I have someone doing a secondary operation? Maybe they're deburring parts while I'm stamping parts. So they're in the area. So they have the ability to be distracted and then get caught up in the machine. And then understand how your system works. Your two-hand controls, how do they work? How does the machine cycle? What happens when I release the buttons? What happens when the machine does cycle while my hands are on and off the buttons? Great safeguarding isn't about installing more safety devices. You want to make sure that you understand your system so that you can use the right devices. Just because you have, well, I put light curtains on the machine, so I'm safe because someone puts their hands through it, the machine will stop. Well, maybe it won't stop fast enough, so light curtains is the wrong device for that machine. Maybe you're in that every 5 seconds changing parts, and you have the stop distance properly for light curtains. Well, maybe a door that's gonna double your time is the wrong device. Well, if I have a door, nobody can go through it and nobody can stop with the light curtain, or the light curtains isn't going to stop them, so let's put a door on it. Well, then you just doubled your production time. So maybe you don't want that on there. So you want to make sure that you use the right devices for the operation. And then I just like to get into how can we help? Because when we do have these webinars, or you're walking through the shop, your factory, you're looking at your machines, it can be overwhelming. So know that you're not alone. Know that this is a common problem. Know that there are people out there that can help you with this. There is an order of operation that you want to kind of go through. We do have webinars on toolkits that if you walk up to the machine and say, I need to guard this machine with, well, first you have to know what the hazard is and know how the machine operates before you can go to the step of how are we going to create a plan? What does that plan look like? So those are things that we can help you out with. If you go to our website, There is bios. We have multiple disciplined engineers. We've got mechanical engineers, application and controls engineers. There's bios on our engineers that if you wanted to read up a little bit on them to help you with this, basically this life cycle of safety. We can help you with that guarding assessment or that safety assessment. So if you have a bunch of machines with two-hand controls and you want us to come in and go through and do that testing for you, we can come in, do the assessment, and in that assessment, we would talk to operators, talk to maintenance. How do you run this machine? How does this cycle? And then we would also look at the secondary guarding options. Maybe it's primary guarding options with two-hand controls being secondary. So we would evaluate all that and come up with some concept safety measures. And then we can do the custom designs, CAD models, solutions with the machine guarding, the switches, the light curtains. We can do all of that. Manufacturing and assembly. We do all of that in-house, where we will take those designs once approved to cut and machine and assemble all of that guarding. And then we have field crews with outfitted trucks and trailers that would then come on site to do the installation, bolted to the floor, bolted to the machine, install the guarding, fill gaps where there might be some areas where you could reach to the hazards, do the integration with all of the tie-ins of any of the safety devices through the monitoring devices, such as safety relays and controllers. And then we can help you with some preventive maintenance. That's an area where you spend a lot of time and money on the guarding. You want to make sure that that lasts a long time. So you want to make sure that you're doing some PM just as you would with changing oil, rotating tires, things of that nature. Here's some examples of different types of machines. You can see the large variety of custom guarding that we do, machine enclosures, perimeter guarding. We've done sound enclosures. We've done manual machines, mills, drill presses, radial arms, lathes. There is levels of safety. As I mentioned, risk reduction. Compliance can be a tricky word. Compliance is hoping people are going to make the right decisions and read signs on anything that we can't put guarding on. If you have to interact with the machine because it's not automated, doesn't have part shuttles to go inside, it's not a CNC that you just close the doors, robots, and you have to interact with the machine of some fashion. I have to make an adjustment. I have to clean this, clear a jam. Depends on your stop functions. So we could help customize guarding that helps in that risk reduction. We do that nationwide. And then that brings us to the end of the presentation. There's a lot of information on our website. There's applications, there's all of our services, different pictures, there's tons of galleries. We're actually revamping our gallery right now to machine types. So if you've got a saw, you can actually go to the saw category and see some of the machines that we've guarded with saws. If it is a press, maybe it's a brake press, you can go into that category. A lot easier to go specific to your needs. And then we have a lot of videos on our YouTube channel. We also post a lot on LinkedIn with a variety of topics. Sometimes it's some fun topics. Sometimes it's some education. Sometimes it's you might want to watch this in your facility because there was some accidents that were related to this type of incident. So good information on LinkedIn to follow our PowerSafe page. And then if you want to schedule, if you've got 10, 15, 20 people on your team and you want to do an exclusive webinar, I have done that with companies before where we can do an exclusive webinar or I'm a guest speaker at one of their virtual safety meetings. Those are things that we can do as well to help you out. So what I'd like to do now is I would like to open it up to any Q&A. that we might be able to answer. And then following this, then we will get all of this information that we just went through out to you. One of the questions is, does the ANSI standard call out the timing of cycle, assuming you can lift your hands? Yes. I will look up that exact number for you in the calculations of what that would be, and I will send that to you to make sure that I give you an accurate number on that. Any other questions I can answer for anybody today? All right, looks like I can give you guys a little bit of your time back today. I know timing for everybody is extremely valuable. So I want to give you some time back today. You will have my contact information that if you want to reach out to set up a Teams meeting, or if you're looking for an on-site assessment, those are things that we can help you out with. Another question, have you done guarding for 100-year-old vertical turning lathes? Yes, this is where the risk reduction comes in. We have to look at how you're loading the machines, what's your material handling look like, what's your stop behavior on it. Usually on any type of turning machines, CNC, e-stop can cause a catastrophic failure to either damaged parts, damaged machines. If there's feed holds on there, and we can just do a process stop. So we have done machines that are old. I actually have some of those on our website that probably don't date back 100 years, but probably is from 50s, 60s, that we have done some guarding on. Risk reduction, try to protect from the spindle, walking up to the table, and then tying it into a feed hold and not a emergency stop. The tricky part on anything that has a CNC control on it, a lot of times that's proprietary, but if there's feed holds on it, usually we can help mitigate that. If there, I think that is a good area that we can explore. I will send you my information that maybe if you have some pictures on the machine, I can send you some more specifics. Any other questions we can help with? If not, I appreciate your time. There's another webinar in 2 weeks that's on machine safety toolkits. Basically, that is to give you some checklists and order of operations, some look into some ROIs. Things that you can do is preempt the audits, just to kind of do your homework, kind of give you a little bit of awareness about where you're at, where your starting points could be. So if that's something that you're interested in, you can go to our training page on our website, and there'll be a link there that you can register as you did for this one. So I appreciate your time today, and hope to see you guys here in the near future.